For our heat transfer project, we chose to compare a single and double glass window. Our group members consisted of Rafael Meza, Eduardo Nacianceno, and Blake Venable. We use windows in our everyday lives. We use them to keep our homes warm during the winter and cool during the summer. For many of us here in Texas, this is a very important topic, especially with the summer fast approaching. For the outline of the project, we consisted of an introduction, an assumption, the method and analysis of a single pane window and a double pane window, the results, and a conclusion. The goal of this project was to convey the importance of installing the right window setup for both preferences and energy savings. This was done by calculating the heat loss for single pane windows and double pane windows.
For this experiment, the following conditions and parameters were assumed for the project. We assumed it's a steady state type of problem. The heat transfer through the window is steady since the surface temperatures remain constant at the specified values. We will also assume the thermal conductivity is constant. Figure 1 depicts the assumed values given to begin the problem. This included assuming a surrounding temperature for both the outside environment and the inside home or business. The convective heat coefficients were also theoretically chosen. Like Figure 1, Figure 3 also shows the assumed parameters for the double pane window. The design of this window was similar but not the same. Instead of having one window, the group added a second window and considered the radiation from the air gap. The design of the double pane window didn't seem so realistic towards the end of the project, however the group continued to analyze the design regardless to retrieve theoretical parameters. This section of the project consisted of analyzing the heat loss of a single pane window. Our goal was to calculate this value using the basic heat loss equation. The second part consisted of calculating the inner surface temperature of the window post the heat transferring occurring. Having assumed some conditions for the problems from the previous slide, the group decided to approach the problem using thermal circuits analysis. Figure 2 depicts the thermal circuit drawn by the group with important values labeled such as the resistance given from the convection passing through the windows as well as the conduction from the glass. Once the resistance values were calculated for both the conduction and convection, the total heat loss could be calculated using the heat loss equation, which can be solved for by dividing the difference in surrounding temperatures over the total resistance. The last step involved finding the inner surface temperature by taking the found heat loss value and solving for the T2 value from the bottom right equation.
In this section of our project, the group analyzed the heat loss in a double pane window. Like the first one, it was a single pane window, so we now are approaching a double pane window. Along with that, the group also calculated for surface temperature in the inner glass location at T4. The goal here was to attack this problem using heat transfer equations learned in the classroom. Like in the first problem, we first start by the thermal circuit analysis. We first draw a thermal circuit for the two-panel window. Our second step was to calculate the resistance parameters from convection, conduction, and now the addition of radiation. Our third step was to calculate heat loss. And our fourth step was to calculate the inner surface temperature at T4 with the calculated value of heat loss. Here we have provided a thermal circuit analysis. As you can see, the only difference is now we have a parallel circuit attached at the air gap. For this problem, we also kept the same equations for the arc conduction, the arc convection, and the arc radiation. For these values, L represents the length of the material, K represents the thermal conductivity of the material, H represents the convection heat coefficient of the material, and sigma is a constant from the Stefan-Boltzmann equation. Upon finding the R equations, we then apply it to the heat loss equations and divide that over the change in temperature from the outside and the inner temperatures. Along with that, we also find our temperature at location 4, which is reapplying it to the heat conduction equation. From our result, we then graphed our results on a Excel spreadsheet, which includes a single pane window and a double pane window. As you can see, there was a big difference in heat loss between both. Along with that, we also calculate the annual cost per year for both the single pane windows and the double pane windows. As you can see here, the amount of dollar for the single pane window is a lot more money than the double pane window. You could tell now that it's a big difference when you install both of them.
In conclusion, the single pane window consists of just the window itself, which acts as insulation. The double pane window proved to be more effective. Furthermore, a double pane window offers a better solution for home or business owners. The installation fee may prove to be more expensive than the single pane window. However, in the long run, the savings will prove to be much better.